Hello everyone. This is Gayatri Priya, Assistant Professor in the Department of EC of RMD Engineering College. So in today's session, we are just going to discuss about voltage regulator under the course linear integrated circuits. Right. So what are voltage regulators? So we all know that the voltage regulators or the integrated circuit which is used to regulate the voltages that is being present up in a circuit. Okay, it just maintains the voltage to be constant irrespective of change in the load current or the input voltage. So here we will be having series or linear voltage regulator, switching voltage regulator. Again in the series or linear we will be having either it might be a fixed voltage regulator or a variable voltage regulator, right? So in the series or linear voltage regulator, we will be having a voltage dividing circuit in order to pick up the desired voltage of the output. So for this, we will be employing a feedback loop, ensuring that the output voltage remains constant, right? So in this case, we may use the FET also, but in case of FET, what happens? We need some consistency driving force over there, right? So these are the popular voltage regulators 78XX. So 78XX in the sense 7805. It is the meaning that the last two digit indicates the constant amount of voltage that is going to be produced. So in this case, if you take 9 volt is going to be the constant voltage that is being produced here. If we look at the advantages in the sense, it is very simple and easy, and moreover it is producing a lower amount of noise, very fast response, and the ripple will be very less. Ripple in the sense unwanted AC component will be very less. But here coming up for the efficiency, it will be very less and it will be occupying more space, thereby making a more amount of heat dissipation. That is, the power will be dissipated lot in the form of heat. Okay, so these things will occupy more space in the PCB, and therefore always we need a cooling fan or a heat sink for this type of voltage regulators. And therefore we are coming up for switching voltage regulator. These are super efficient regulator which makes use of the scenario that is where power loss is not conducted, right? So here also it produces a rapid switching, okay, but at the same time it will be making the switching element either in a fully conducting or fully switched off state, thereby producing a high level of efficiency. So these are the advantages and disadvantages of switching voltage regulator. So advantages: smaller size, high efficiency, output voltage will be greater. It fits whatever the power applications. But coming up for the disadvantage, very complex design as well as it need more number of components and thereby the cost will be higher. So whereas your series voltage regulator has less noise, here it is going to produce a higher noise. Also the ripple content is very high. The transient recovery time is also very slower when compared to the linear regulator, right? So linear regulator in the sense, if the control element is placed in series between the input and the output, then that is called series or linear voltage regulator, right? So for this you can accomplish by making use of an operational amplifier in which the non-inverting terminal is connected to a Zener diode. That is, this part will be responsible in providing a unregulated DC voltage to a regulated DC voltage of around some 5.7, or depending upon that Zener diode specifications, you will be getting a reference voltage. So to the positive terminal. In the negative terminal, we will be having a voltage dividing circuit which will be acting as a negative feedback. It will be keep on tracking the voltage present at the inverting terminal, okay, and it will be compared with that of the reference voltage, and this difference voltage will be given to the series pass transistor, which will be making the circuit whether the switch is turned on or turned off is determined using this case, right? So for this the response everything is being given up. Hope you understand this session. Thank you.